Item B under new business, Project Lead the Way. Matt Duncan, Leanne Tumbrink, and Mr. Bryce Swafford will report on Project Lead the Way. Thank you for being here. Leanne changed her shirt.
You go one hat to the
Talk about
next
changing
hat,
hats, but we're doing changing shirts.
Well, and Bryce has got a contraption or two.
Oh, he's got some cool stuff too.
This one looks like it flies.
Before I get started, I forgot. I wanted to say thank you to Monica, too. The junior high had a little fundraiser for our robotics. I forgot to mention them. So we had lots of support. Thank you.
So you're going to tell us about Project Lead the Way.
Project Lead the Way. Our presentation is based on that there's a general knowledge of Project Lead the Way, but Project Lead the Way uses lots of acronyms, so we're going to kind of try and refresh in case you don't know what they mean. So sorry if you know, but we'll try and fill in the holes here. Okay, we're going to go. There we go. Okay. Let's see. There we go. So we have last year in May, our Project Lead the Way program went through a recertification process. We had a team that visited our facility, and we just wanted you to see what they gave us, the strengths, the weaknesses. Two of the pages, I believe, are from that actual report. The extra page, one of the things that at the beginning we did not get full certification. We had a provisional certification with the one condition. And Mr. Duncan addressed that issue, and then we received our full certification. So you can see how he addressed it and some of the issues that were on there. So the main thing I think that is the biggest concern of the committee that visited us is our time restraint. At RTI, with the busing issue of the Raleigh students, by the time they actually get to class, get settled, and then have to hurry up and pack up and leave, we lose enough instructional time that there's about 35 minutes total instructional time. And when kids are there for blocks of time, that's okay. But when they're only there for 35 minutes and it's a curriculum intended for at least 50, and even that it's pushing it for people to get the curriculum done, there are times when I have to skip some major items because we just don't get to them. I've been trained in several of the classes, and I've asked my master teachers at those trainings for any suggestions, and they're like, well, you could just treat it like a regular classroom and take out the activities. And I'm like, no, I can't do that.
Look, for the people that might be watching and that don't know what Project Lead the Way is,
Let me
and for
see.
many people on the board who've not
Sure,
interacted,
sure.
can you just kind of give a 101
Yeah.
version of what Project Lead the Way is?
Yeah. Okay, Project Lead the Way is an engineering course curriculum. It starts out, actually they're changing it. There actually is kindergarten through senior now of engineering curriculum. And I believe at RTI, have we had it for 10 years, Matt? So we have the high school curriculum at RTI, the two basic courses, which we'll talk about them, and then we also have an 8th grade course now. So we are expanding, but Project Lead the Way, the reason they call it Project Lead the Way is because that's the name of the company that makes the curriculum. But it's actually engineering courses is what it is. And so what this is right now, we're talking about our engineering courses, and it's meant to be hands-on. That's what Project Lead the Way means it to be, is hands-on, so that you learn how to be an engineer, not just from sitting in a calculus class, but you learn how to build bridges, you learn how to do things hands-on and see what it's like to be an engineer.
And robotics is a component of...
Yes, robotics is a component of what we do in robotics is exactly what we do in engineering. and we're hoping that the two help each other out a lot. So, but anyway, we just wanted you to know that we did come up with an idea on how to solve the problem. It's, we still can't get the full 48 minutes. We are going to investigate other areas of maybe block scheduling or something. But you do realize, like you notice with our robotics kids, these kids are busy. And they have AP courses. They have lots of requirements that they have to fit in that schedule. And putting in another elective, an engineering course, by the time they're seniors, it's hard to get them in there. And so we're working with a lot of things that, if I had them come over for 2 hours, I would lose a lot of my students. We're lucky because they can come over as a 1-hour course. We're just trying to get the busing faster is what we're working on. So we are certified, fully certified now for 5 years, and they'll be back in 5 years. Okay. There we go. Now, I like to show this to people because they say, why put engineering as a career tech educational course? Well, I can take this from experience. If you want to send your son or daughter to an engineering school and pay $22,000 for them to be there without ever finding out what it means to be an engineer, sorry. My son's there. He went through all of my engineering courses, and he knew when he started that's what he wanted to do. And he knew what fields of engineering he liked and what fields of engineering he didn't like. And so, to me, if my son or daughter came home and said, I'm good at math and science, and my counselor told me I need to be an engineer, I'd sign them up for Project Lead the Way, the engineering courses, so they can see. Because I find myself telling my kids, whether you like it or not, I feel like I'm successful. If you find out you don't like it, then you won't go to a college and waste mom and dad's $22,000 because you're good at math and science, but you're not good at engineering. And so it is so important that we have our kids that are interested in engineering or being led that path, even though they have no clue what engineering is, that they try these courses and get a hands-on way of learning what engineering really is. Because it isn't just being good on math and science on paper. There's a lot more to it than that. Oops, I went the wrong way. There we go. Okay, our courses at RTI. That's a list of all the courses that we could offer at RTI. The first one, Gateway to Technology, we call it GTT. That's Mr. Swafford's course, the 8th grade class. Introduction to Engineering Design and Principles of Engineering, IED and POE. Those are the main basic courses that they require the high school kids to take. So those are the core courses. Digital Electronics is an elective course that you can't take until you've taken the 2 in red. Civil Engineering, CEA, is also an elective. Aerospace is also an elective. And Engineering Design and Development is also an elective. Right now, I'm trained to teach digital electronics. We have offered it, and we've had enough kids take it, I think, once. Civil Engineering and Architecture, we've offered it, and occasionally we've had enough kids sign up to take the course. We're hoping next year Aerospace Engineering, Mr. Swafford is going to train for it this summer. And it's on the books to be there next fall. Engineering Design and Development is the senior course. And they have to have the 2 red courses and 1 elective, and then they can take EDD. That one is where they come in and they invent something, and they actually go to a company and have it made, and they market it. And if they want to, they can patent it. And somebody asked me at my teachers, where the teachers came in for professional development, we told the junior high and high school teachers about what we did at RTI. And I said, wouldn't it be amazing your son or daughter be able to graduate from high school with a patent? And they're like, okay, who would get the money from it? The high school, or would it be, or who would it get? I'm like, I don't know. That's a good question. I'd like to find that out someday. So how amazing would that be, to have students standing in front of you before they graduate and say, we patented this idea, we made it, and people are wanting to buy it. I mean, that's pretty amazing. So anyway, I'm going to let Bryce talk about Gateway to Technology, since that's his baby.
All right, 2 years ago, I did the GTT, Gateway to Technology training with Leanne Humbrick. She was my sidekick for that whole time. She carried me through it. The training's kind of brutal. It's actually 2 weeks, 10 days, from 8 to 5, plus about 2 to 3 hours worth of homework every night. And it's pretty intensive because you learn the whole curriculum within those 10 days. And it's every project you'll do throughout the whole semester, you actually go through it. In GTT, we start very basic. We talk about engineering, what engineering is about, what do engineers do? Well, what all engineers want to do? Make our lives easier. And that's what we really try to engage those 8th graders. She has a lot of overflow from my kids that actually took GTT actually in her robotics team, which is exciting for me to see those kids go in there and also those kids roll over and actually be in that freshman class too in IED or POE. We start pretty small, and we start with robotics. We're trying to do the same thing again, time constraint wise. We're down to the same thing, about 30, 35 minutes worth of work time. And for those guys to get in there and get going pretty quick, we kind of hit and miss some of the major points of the curriculum, but we really want to hit the Project Lead Way is all the fundamental things we do and to get their hands dirty and get building. The first thing we do in robotics is we do a simple programming software program. This is a makeshift test bed. We add all our components to it, whether it's a line reader or a light sensor. We have motors and sensors. We have potentiometers, limit switches, and buttons that are all touch sensors. This is what they call a cortex. This cortex is basically the brain of this, and the kids actually learn about how to program. The programming language is basically you say what you want it to do. So if I push this button, it's going to turn this motor on. And then you have to tell it in robotic language how long, how fast, how slow. Does it need a reverse power? Go from there. So they do all that programming first. They learn it through the test bed. Then we do a simple build. One of the simple build is basically build me a car that goes as fast as possible in 20 feet. The first thing the kids in, can I put 4 motors on there? No. You're limited to 2 motors, has to go exactly 20 feet, and you have to use a button to make it go. A lot of them will just put 2 motors on it, and that's after we do an extensive research and design process of gears and fixtures, gear ratios, make things go faster. And I put 1 motor on with a big gear and a little gear, and mine smokes them every single time. Like, how'd you do that? I got 2 motors on there. Well, mechanical advantage. You guys didn't pay attention. So then some of the most complex ones we do is a pick and place. This is a very simple one. This was actually developed by one of our students that came in. I fell out of the motor. Came out of the motor. Get in there. We'll just hold in there. This one actually, a foreign exchange student came down here. He was here for 6 weeks. And he picked it up that fast. That's how important this program is, because he came in, he didn't do any of the test beds. He came in the very beginning of it, or the very middle of it, and he was actually developed and actually started programming this one, where he had actually the 2 buttons would actually rotate it, and he had to move it forward and backwards, and he actually had the car would open and close. Some of the other ones are not up here. Is an elevator shaft. They actually developed a program it for 3 floors to go up and down, stop and start on those. So that's the robotics part of it. The last thing is we haven't been able to get to yet, but they actually will compile a huge, what is it? I lost my train of thought. Yeah, no, in robotics. Elevator, it's a mass production where they actually develop, everybody will develop a different part of that mass production, and each component has a conveyor belt and actually will go through the whole part, and everybody has to work together to make it go. And we'll simulates the making of a part. We'll actually drill a hole from downside to the left side and move forward. And the next component will actually go from there. So it's actually pretty cool. One of the last things we do, or some of the, can you hand me that? We actually go through Inventor. Inventor is a 3D software program. You draw everything in 3D. And it's kind of analytical thinking. And we start very basic. We do like a peg game drawing where they actually develop a little peg game. They'll draw it flat in 2D, they'll extrude it to depth and width, and then from there they'll expand it out. The last thing we're doing right now is actually they're going through and we give them a problem, and basically they're building a playground set that actually goes through it, and all the parts and components you have to make through it. I'll pass it around so you take a peek at it. You actually go through there, you build all the parts, and the thing that's amazing about Inventor is all you do is draw that part one time, and it's there for life. If you make any changes on it or whatever it is, it changes it from the from initial drawing to working drawing to inside the major part you have. From there, you assemble it, and you actually go through it, and actually you'll see it as a 3D model. You actually draw it with true size and actually true shape. You can do everything you want with it. From any of those parts you can do, like Leanne said, like some of her robotics team did, you can actually design and build a gear. You can actually get it to a 3D printer, print that gear out so that actually you can usable parts. So it's a very, very powerful program for those kids to understand and get used to it. Basically, we go through that, and then I'll be teaching or going through training again this year, this summer for aerospace and engineering, which is AE. In that program, basically, we are going to go through the flight aspect, rocketry in space, learn how to fly a bit, and then one of their major projects is actually they'll basically make a lunar moon rover and actually go across a 2x4 and actually take pictures of the ground, and they'll take that data and make a map from that data. So that's one of the upper levels, what they're able to do. So in a nutshell, that's basically a GTT and A&E. It's only a semester, yeah. Yeah, mine's only a semester. Right now, we're running 2 sections of it. Both sections always been full. The first year we did it, we filled it up. Last year we were a little short, and then we get about 80 kids throughout the whole program. So we have to, if I didn't have the DEPCO modules over the junior high, my class would be totally full, maxed out. So we capped a limited 20 kids because each kid has to have their own laptop. When we do adventure work, it's all, project-based learning.
Bryce, is this year 2 or year 3 for your history? I can't remember.
Year 2.
Year 2.
Yeah, year 2.
So the program has been around, we used to start with the principles of engineering. The IED was level 1. It's just in the last 2 years that we've been able to have the 8th grade program to try and expand that a little bit and get more kids into it.
So Bryce, are you at the junior high or at your?
I'm at RTI because me and her share the same classroom. And same thing again with the robotics part of it. We have to have, by rule, you're supposed to have 5 robotic kits per 20. So you get 5 kids on 1 robotic kit. And then we also, same thing again, we're borrowing and sharing a lot of stuff too. So then we can break down our groups a little bit smaller. But if our class gets bigger and bigger, well then we have to get bigger and bigger groups. So I try to keep a minimal between 3 and 2 people in a group, which they get more hands-on stuff that way. A lot easier to learn that way. But it's a lot of fun. Kids get a lot of fun out of it. Like I said, they can pick it up pretty easily. It's very easy to learn from that.
So when students go through this, Bryce, and like we have academies also, right? And I'm kind of picturing this like one of the academies. If they finish it, there's a course they can take basically all through until they graduate from 8th grade on. Am I thinking correct?
Correct. Every year you can go on to the next one. So mine's the beginning of it. And also there's actually 4 more sessions that we could actually teach at the 8th grade level. There's actually aerospace and flighting, that one. There's environmental engineering that I do with my women in technology class. They actually go through and they actually build a wind turbine. That was ours during training. They actually go through that and they'll learn about heat loss and environmental training where, within 55 years, there's no more oil. What are we going to do with that? The wind energy, how we can create that. From there, they step up and do the IED and POE, and then you're going to do one more learning one. And then by the time they're senior, that's where we want to be at. And by the time they're senior, you're going to start weeding out your kids.
Sure. And
so you're not going to have a huge group. I mean, you might have, if you have 8, that'd be awesome.
Right.
Same thing with aerospace and engineering. If we had 10 to 15 would be even perfect numbers. But, first time doing it, we're going to have probably pretty low numbers until the word gets out, say, hey, I did these 2 classes and I was able to take digital electronics. I learned how to repair iPhones. I know what all that's about. And I took aerospace engineering. I learned flight technology. And then they go on to the biggest one is the last part when they actually go through the patent process of it. And that's what they want to be able to do, so they actually understand the whole process of what goes behind an engineering part of it, and what's in your notebook is actually a legal document as an engineering notebook. What you write down in there, no matter how small or silly the ideas, they can always become great ideas later on. And that's actually a legal document, and a lot of kids don't understand that. And then the biggest thing is those patent things is basically the first semester you're going to research all the patents out there. and you're gonna see what's wrong with that patent before you even attempt to fix it. And then you have to research that patent to make sure it wasn't fixed before. So there's a lot of research behind that, and that's what engineers do. When they have to do so much research behind everything before they actually be able to make that part and actually go out there and patent it.
So there's an obvious advantage to them when they are, graduate, whether they go to a professional program or go to a four-year school, engineering, what have you. Are there other, because some of the academies, there's even like potential certifications and things like that. Are there other carrots out there for students?
The biggest thing with Project Lead the Way, there's a lot of scholarships available for them when they actually go through it. With MS&T in their backyard, they actually will honor a lot of the classes they take.
Oh, really?
College credit.
Outstanding.
I can't remember her name, but she went over there. I think she was on a full ride, wasn't she? A couple years ago, she went through the whole. I can't remember, but I know that you're able to roll over and take in some of those mediocre classes that you already know about. You actually be able to step up and take the
Go
next
beyond
level up.
that.
So
Cool. That's great.
there's a great advantage just going through the whole program. But like I said, we're going to start out with 80 kids right now, and then over time you're going to start losing those numbers. And really, by the time it's all said and done, you're going to basically only have a small team of 10 to 8 kids to go through the whole program and go through that patent. When I was doing the training, what they did actually, one people actually went in there to design a new iPhone clip holder, but they put the credit card in. It's out now. You slide your credit cards in there, but when they turn it upside down, credit cards will fall out. So they did all the research behind it, and all they did was add a little tab to it, so put a little pressure on it to hold it down. And they actually took it to a 3D printer and printed it off and actually made a usable product of it, and that's pretty sweet.
That's real sweet.
Wow.
Yeah. So 3D printers on the budget. Just let's FYI that. So just sneak that one in there for you. But some of those things you can look at there, and just to have those kids hold those parts and say, "Oh wow, that's pretty cool." We're not down. Robert Stutter and we took a group down to Pittsburgh State University. They had a 3D printer that actually would print out the whole house, and they did some Google imaging and all that stuff. And from the 3D printer, you can actually go up to 1/64 of an inch in detail. So they actually made a huge operating room for a doctor, where the doctor would go in there and see exactly what the room would look like. And he noticed that the clock was on his left-hand side. Well, he wanted it over here because he was right-hand dominant. So that was a change. He had to make that change because when I want to look up, I want to see the clock in my right eye. So those are the things that are out there. The technology is out there, and that's what engineers want to do, is make your life easier for you guys. So that's what we're trying to do. All right, I'll turn it over to Leanne.
So Leanne, Bryce, when you're ready to talk about patents, give me a call. I'll come over and give your students 20 minutes on patents.
There you go.
And I'm pretty sure they'll own the rights, not the high school.
Really?
It would be the school.
Yep.
So just stay up here. He mentioned real quickly some of the things that I teach. The Gateway program is meant exactly for that. It's a gateway. It introduces the kids to what Project Lead the Way is all about. And so they do a little dabbling of everything. Well, then when they get to the high school class, which basically is the freshman class, then all of a sudden they kind of grumble at me because they go to building this kind of stuff to everything's on the computer. And it's like, are we building stuff? It's like, no, we got to back up. We got to learn again. What's the design process? What do you have to go through to actually design something, to work together to design something and actually write it down? The engineering notebook that you saw with the robotics kids, I'm finding the smart engineering kids hate writing things down. They just want to jump right in and start working. And they don't, and we're trying to teach them in this first course that it's a legal document. They have to prove it was their idea. They can't just start building, because then who's going to say that was theirs to begin with? And so we teach them the design process. And then one of the things in the very first course that we teach them is how to make things on Inventor, which that's a picture of the train and the puzzle cube. That's their main big projects. And except for the design process and the engineering notebook and how to sketch things accurately and label things accurately, the biggest thing of that course is Autodesk Inventor, and it's such a good tool for anybody who's really out there building things. Somebody can make something 3D and see if it works before they ever spend a dime. And companies like people that have that ability. So we don't even have to have 4-year. I mean, I went to the Lynn Technical College, and they were teaching their sophomore kids their second year, their associate's degree, what I was teaching my 9th graders. And I was telling my kids, you know, if you don't want to be the 4-year degrees boss, if you really like inventor, you can go and you can make more than I do now starting out. I said, isn't that amazing that you could do that? That with what I'm teaching you right now, I am really preparing you for something that you could do as a skill for life if you really liked it.
And then on top of that, Inventor is a very powerful software program. And the biggest thing, we spent probably 20 hours doing it over the summer, just to get the basics of it. But every instructor we talk about, it'll take you about 5,000 hours just to master the Inventor program.
Wow.
I mean, that's how incredible and intense that program is. I mean, it's huge. You can do anything you want. You can build, manipulate, even add animation to it. And the crazy thing with some kids don't understand is we make a working drawing from there. And like I said before, all you have to do is draw that part one time. From there, you can put it into a working drawing and actually dimension that drawing inside that working drawing. So let's say you had a change of that part, it was too big or too small, but you go back to your original drawing, edit that sketch, and no matter what, you come back to your working drawing, it fixes it right away. So there's no more pen and paper anymore like it was in the olden days. It just changes it so much, and some of those kids are fascinated about it. Like, oh wow, it changed. Yeah, it does. So it's a very powerful program.
What is your certification in? I know you have to take the classes from Project Lead the Way, but what are your?
Mine is math. I teach math at the high school.
I'm an industrial technology education.
And when I took the second course, the POE course, I actually started out in that one. I had teachers in there that were English teachers, you know, and as the math teacher, I had an advantage because I remember this person was drawing all these right triangles and doing trig up there, and this poor lady raises her hand and goes, "What's sin, tan, and cos?" And I'm like, oh goodness, she's going to have a lot to learn after these 2 weeks because, like Bryce said, they just throw it all at you in 2 weeks. You learn everything that they do in a year, and amazingly, we all learn it just as much as they do by our hands-on what we do with our activities, as much as the paper that they give us. So the second course is Principles of Engineering, and that's the course where after they've learned how to design, after they've learned how to work together and come up with ideas, then I give them problem after problem, and they build things to solve that problem. And we have mousetrap cars, we have Rube Goldberg machines, we have levees that the National Guard has given us all the equipment for, and the kids make levees and figure out what type of material to use. Sometimes they don't think too hard about it. I had one group that made their levee out of potting soil, and I'm like, did you think that potting soil was made to have water go through the soil, not keep it from going? And oh, okay. So, you know, sometimes they do put a ton of effort into it, and they're very competitive, and sometimes not. But they do have a lot of fun, and in the fun, they're learning. That's the best thing, is that when you walk into our classroom, it's a wreck. But it's not a wreck because we're not taking care of it. It's because those kids, as soon as they hit that door, they're working on something, and oh, we got to go, and they're out the door.
I see, that time limit is really bad, though.
Yes, it is.
it's gotta
And
be.
As a former art teacher, I know when you get it all out, then you got.
yeah, and I do know as a math teacher, this is my 22nd year teaching math. I don't think I've ever had any of my students, even when I taught upper level math, say, "Can we just stay longer? I want to be in here more." I've never had them say that in my math classes, but they say that in our classes all the time. This really needs to be longer. We really need more time. And that's really a good feeling because you know they really are getting something out of what you're teaching. You know, I taught math a long time, and I've pushed a lot of worksheets, but it is really amazing to teach a class where I'm teaching them how to do summation, and this is why, you know, because now we're going to figure this this board centroid, and this is in a bridge, or you would need this, and this is why we're doing this complicated math, because you need to know that or your bridge isn't going to work, you know, and so they finally see, why am I using this? They never asked me that question. That's why these kids are so bright already with the math and the science that most of the time we're teaching them things that a lot of times they've seen some of it, but they pick it up quicker because it's applying. It's the application. I'm not giving them a worksheet just because on statistics now all of a sudden they're looking to see what would be the best. They make ping pong shooters, and they have to do practice shot after practice shot, and they do all this data and they collect it, and then I put a bucket out there and I'm like, okay, you get an A if you can make it in 3 shots. And I say, here's a random length, and they have to look at their data to see how far away and what angle they're going to do their ping pong shooter. And so it sounds silly, but it's application, and that's what engineers do. They write things on notebooks or on napkins, and they come up with real quick ideas, and then eventually they toy around with stuff like this, and they make the ideas work. And then we have digital electronics, which is a course that we've only offered once, and we've had a few students. Next year we have one returning sending school student that I think is going to take that in my class amongst my other 2 classes. We have a really hard time with our electives, getting the numbers, because of just competing with the other things that they have to take. So I know we're talking a lot. We're pretty sold on it. We have civil engineering and architecture. They get to actually learn how to do all that it takes to make bridges and roads and buildings, and then we have aerospace, like Bryce mentioned, that we're really excited is going to be there next year, and EDD. So we've gone through the gamut. Missouri S&T does offer, if you take the first 2 courses, IED and POE, as long as you get a good grade, I think it's a B now, at least a B and at least a C on their final, which, by the way, the finals are not mine or Bryce. Well, Bryce doesn't have to get finals. I give an EOC that Project Lead the Way gives me. So they mean it to be stringent. POE is a challenging mathematics and science course. And when they take that final, it's a college course. It's a college final. And I think they want to make sure, the company that makes this wants to make sure that nobody waters it down. And when the college looks to see that those kids got at least a C on their final, that's a college final. And they're then giving them the credit for it. For IDE 20, they would get to skip that basic engineering course. So that's in a nutshell. The last thing we're going to talk about real quickly is TSA, because there's some confusion. TSA, for me to get funding, and I'll let Matt fill in the details just a little bit, for me to get funding from the government as a Project Lead the Way class, I have to have my kids be a member of a CTSO, Career Technical Student Organization. And Project Lead the Way has teamed up with TSA. So my students, unlike Skills USA, which some of you have heard of, my students would have to be members of TSA, and they are. Well, part of TSA is like Skills USA, there's competitions. And one of the competitions in TSA is a robotics competition. But it's not my robotics I shouldn't say it's not mine. It's not FIRST robotics competition. It's VEX robotics competition. This is VEX, okay? And so as we have students that are getting more involved in TSA, because I'm required to get them more involved, if you hear anything about any robotics competitions with VEX, it's this stuff. Now, VEX robotics is completely different because I don't know a lot about it, but what I've seen is they all kind of build the same robot, and whoever can compete the best with it, they win. So there's not as much creativity. And this stuff, you see this.
It's all plastic
it's
gears.
Plastic.
It's non-metal gears. The stuff she does is basically, high-end aluminum, steel and stuff like that. A little bit lighter, a little bit easier material to work with. And this is all pre-made stuff, and the stuff that's for classroom. What she does is something totally different, and it's a 2 levels different competition. So you got the upper, and then you got your middle, and hopefully maybe we do the VEX, we can roll those kids over into the upper class. And so this is just like an introduction to the robotics team phase of that.
But Matt, you want to tell them what exactly, why we have to do this?
First, I just want to say thanks. It's been it's a lot of scheduling with the high school. Mrs. Fulton and Dr. Pritchett, we share their schedules. We're excited. It's great having that many 8th graders in the building. You know, we've got about 80 8th graders that come over 2 hours a day. Next year we'll be looking to add another hour with the aerospace. Excited about that. Mrs. Tumbrick's schedule is a challenge to do that at the high school with her math, and both buildings that works out great. So that works out really good. The challenges that we have, as she said, are the travel, the accreditation, and again, Dr. Pritchett and Mrs. Fulton's been involved with that accreditation as well. So it's a great partnership just to try to make this succeed. The TSA is very similar to any other CTSO or Career Tech student organization. It's like the Skills USA or the FFA, FBLA student organizations, and for it to be career and tech ed, it needs to fall into the same guidelines. We're able to access a lot of the vocational money. The computers, the laptops that they're talking about are very expensive. They're high end. Yeah, they're expensive. We're able to get that. If we could get the 3D printer, we're able to access it at a really nice matching grant that we've been successful to utilize through there. But if it's vocational funding, then it needs to be a vocational program, and that's one of the things that we're working on now is to establish a TSA chapter. So.
So you guys have any questions or we can talk along?
So you both have roughly half a day at the traditional school and then half a day at RTI for each of you?
Yeah, I teach 4 hours over at Butler Junior High,
Yeah.
and I teach an advanced 9th grade class. I've already talked to some of the Miss Monica about it and try to figure out whether or not we need to eliminate that class or move that class over and try to get them more involved in the robotics, stuff like that. So to increase our numbers more and more. Because like I said, and what she said, is these kids get over there and they're just so excited to get in there and start building stuff.
Oh, hands-on.
And then it's all hands-on. I mean, basically they sit around just, I wouldn't say play all day, but play while learning. How about that? Play while learning.
And I'm over at RTI actually most of my day. This year I had 2 math classes. Next year, because our POE numbers have grown, so now I'm going to have 2 POEs. So now I'll have 1 math class. So I love teaching math. I've done it forever, but I love this. And to actually get a program where I'm at RTI every hour, you know, being full every hour, I'd love that because this means a ton, because I feel like I'm preparing my students for a job, really. So, but yes, I'm over there at RTI most of the day, so I'm really considered to be, I go to RTI's meetings. I'm more RTI now than I am at the high school anymore.
Good.
Great.
Great. Thank you
Thank
so
you.
much.